Two strings. One question. What is the longest sequence of characters that appears in both in order? Master this single pattern and you have half solved 6 of the next 9 problems. They all reduce to this. Here is the problem. You are given two strings. A subsequence keeps the original order, but is allowed to skip characters. They do not need to be next to each other. Take A, B, C, D, E and A, C, E. The longest common subsequence is A, C, E with length 3. Now think like a dynamic programmer. Ask, what changes between subproblems? It is how much of each string we have looked at. So our state has two indices. F of I and j is the length of the longest common subsequence using the first I characters of string 1 and the first j characters of string 2. The final answer lives at f of n m. The recurrence comes from one comparison. Look at the last character of each prefix. If they match, that shared character extends the answer. Take 1 plus the diagonal f of I minus 1, j minus 1. If they do not match, drop the last character of one string or the other and keep whichever is better. The maximum of up and left. The base case is simple. An empty prefix shares nothing, so it is 0. In code, this is beautifully short. Build a grid of size n plus 1 by m plus 1. Loop over every I and j. If the characters match, take 1 plus the diagonal. Otherwise, take the larger of the cell above and the cell to the left. Notice the index shift. The cell I, j compares character I minus 1 with character j minus 1. Watch the grid fill in. The first row and column are zeros, are empty prefixes. When characters match, we step diagonally and add 1. When they mismatch, we copy the larger neighbor. See the staircase of matches forming along the diagonal? The bottom right cell, 3, is our answer. One more refinement. Each row depends only on the row above it. So we never need the whole grid. Keep just 2 rows, previous and current, and the space drops to order m. We will skip this trick next time when we need the full table to rebuild the actual string. The complexity is clean. There are n plus 1 times m plus 1 states, and each takes constant time to fill. That gives time order n times m and space order m after optimization. Two pitfalls to avoid. First, the index shift. Prefix length I maps to character index I minus 1. Get this wrong and everything is off by 1. Second, do not compare the whole strings with equals. Compare only the two boundary characters. Here is the reflex to burn into memory. Match, step diagonally and add 1. Mismatch, branch and take the best. Every string problem this module is just a variation on those two moves. We now know the length of the longest common subsequence. But how do we recover the actual string? That is exactly where we go next. See you there.